very good morning to all of you. I welcome you once again to this current video lecture. In the last video lecture, we completed the second chapter from the syllabus, that is called as chemistry of hydrocarbons, that is alkenes. So we completed that alkenes in the last video. Now in the current video, we are going to start the next chapter from the syllabus, that is the chapter number 3. It is called as the chemistry of hydrocarbons and it is alkynes. So the last part from this hydrocarbons we have to start in a current video lecture. So that is called as the alkynes. So we completed the two important part from the chemistry of hydrocarbons, that is called as the alkanes and alkenes. Now in a similar way we have to consider the third type or the third important part of this hydrocarbons, and that is called as the alkynes. Before taking the actual points from this chapter, first of all we are going to take the introductory part, the important introduction regarding these alkynes. So as we know that as that of the alkenes and alkynes, this alkynes is also called as the hydrocarbons. It is a hydrocarbons, especially it is called as the unsaturated hydrocarbons. This is called as the unsaturated hydrocarbons. This is a unsaturated hydrocarbons. This is the unsaturated hydrocarbons. Now what is by unsaturated? Unsaturated stands for the presence of either double bond or either triple bond. So these alkynes is called as unsaturated. Then what type of bond is present in these alkynes? So we know that double bond is present in the alkenes. So in this case what happens? Unsaturated hydrocarbons containing C triple bond C. So C triple bond C is present in a given hydrocarbons, then that hydrocarbons is called as the alkynes. So we define alkanes as the unsaturated hydrocarbons in which the carbon-carbon triple bond is present, then that hydrocarbons is called as the alkynes. So this is a simple definition of these particular alkynes. The second important thing is that these alkynes, the general formula for these alkynes is a CnH2n minus 2. This alkynes has the general molecular formula as a CnH2n minus 2. This is a general molecular formula for these alkynes. If we look toward this general formula for these alkynes, what happens? These alkynes have the 4 hydrogen atom less as that of the alkanes. As compared to alkanes, 4 hydrogen atoms are less in this particular alkynes. So this is a general formula for this particular alkynes. The next important thing is that these alkynes have the functional group. What is the functional group for these alkynes? So the functional group for these alkynes, what is the functional group? So it is a C triple bond C. So this carbon-carbon triple bond is called as the functional group for these alkynes. So in each and every alkynes, this C triple bond C is present. Next thing is that what type of reactions can be given by these alkynes? So we know that since this functional group is a C triple bond C, so the reactions given by these alkynes is nothing but the reactions given by this particular C triple bond C. So these are the reactions given by these alkynes. So what is the reactions? So reactions first of all given by this C triple bond C as well as by the bond triple bond C single bond H. So these two important parts in the particular alkynes takes place in a particular chemical reaction. One type of chemical reaction is given by these alkynes in which this C triple bond C is involved, while in a second type of chemical reaction this triple bond CH, this C single bond H is involved. So these two type of important chemical reactions can be given by the this type of the alkynes. Next, as we know that alkanes and alkynes show one important characteristics, and that is called as the homologous series. The homologous series can be shown by the alkanes as well as the alkenes. In a similar way, these alkynes also show one important type of series, that is homologous series, but in this case that series is called as the acetylene series. That series is called as the acetylene series. Acetylene series is shown by this particular type of the alkynes. So we can say that these are general important features of particular alkynes. What is alkynes? What is the definition of alkynes and other important parameters? So first of all, what is alkynes now? So alkynes is defined as the unsaturated hydrocarbons containing carbon-carbon triple bond is called as the alkynes. The general molecular formula for these alkynes is a CnH2n-2. Nextly, what is the functional group present in alkynes? So the functional group present in alkynes is C triple bond C. This is called as the characteristics group, or it is called as the functional group. Next important parameter is that what are the important reactions given by these alkynes. So two type of the important reactions can be given by these alkynes. In a one reaction, this actual involvement of C triple bond C can be takes place, while in a second type of chemical reaction, the involvement of this triple bond CH, this CH single bond takes place in a particular chemical reaction. And at the last, one important type of the series is shown by this particular alkynes, and that is called as the acetylene series, same as that of the homologous series shown by the alkanes and alkenes. Next, one important characteristics is there for these alkynes. If we compare these alkenes and alkynes, there is a large similarities present between the chemical properties of these alkenes as well as these alkynes. So we can say that alkenes and alkynes have the similar characteristics or similar behavior can be shown by these alkynes as that of the alkenes. So this is a general introduction regarding this type of the alkynes is there. Once we finish this type of the general introduction of these alkynes, we are interested to study one important parameter of these alkynes, and that is called as the nomenclature of this particular alkynes. What is the nomenclature? What are the different rules? So that we have to take now. So we know very well that the two important methods are there for assigning the name of the organic compounds. So as far as the nomenclature of these alkynes are concerned, so these alkynes again have the two different type of the methods for assigning the names as that of the alkenes and alkenes. So first of all, the first important method for assigning the names is called as the common names. This is a common name, or it is a common name system is there. So the first important method for assigning the names is called as the common names, or it is a common name system for assigning the names of a particular alkynes. Now, how to give the names according to this common name system? So for this purpose, what is the first important example of this particular alkynes? So what is the first example of these alkynes? So we know that this alkynes is nothing but the compound containing the carbon-carbon triple bond. So the first starting example of this compound is a H single bond C triple bond C H. So this is the first simple example of the alkynes, that is a H single bond C triple bond CH. Now what is the name of this compound? So this compound is no doubt this is alkyne, but according to common name system, the name of this compound is a acetylene. This compound is called as the acetylene. So this is the first example of the alkyne family, acetylene. Now once we know the name of this particular first example of alkynes, it is very simple to us that to give the name of the remaining alkynes. So according to this common name system, the alkynes can be given the names according to the derivative of this particular acetylene. They are given the names on the basis of derivative of which derivative? Derivative of this acetylene. So we can say that this acetylene is a parent word while giving the names to the alkynes on the basis of common name system. Let us consider one simple example for this purpose. So I take here a simple example as CH3 single bond C triple bond C single bond H. Suppose we are interested to assign the name for this given alkyne compound according to the common name system. Then how to assign the common name? So it is very simple. First of all, we know that this is nothing but the derivative of acetylene. This is nothing but the derivative of acetylene. To form this compound from this acetylene, what we have to take here, or what we have to do here? We have to just replace one of the proton of this acetylene by the methyl group. So we can say that this compound is nothing but the derivative of acetylene. So whenever such a type of compound is there, it is very simple to give the name according to this type of the derivative of acetylene. So what is the name of this compound now? we derive this compound from the acetylene just by the involvement of this particular methyl group. So the name of this compound is a methyl acetylene. This compound has a name as a methyl acetylene. This is a simple common name for the compound. Methyl stands for the CH3 and acetylene is a remaining parent compound. So it is a methyl acetylene. In a similar way, if I take the next examples now, for example, if I take here CH3, single bond CH2, single bond C, triple bond C, single bond H. Now in this case, what I have to take here? We have to take into consideration what type of group or what type of moiety we can add in this particular group. So if we compare acetylene to this compound, what happens? This H get replaced by one group and that group is a CH3 single bond CH2. So this is nothing but the again derivative of this particular acetylene. Now what is the name of this group? So this group is called as the ethyl. So name of this acetylene, so the name of this compound is a ethyl acetylene. This compound has a common name as a ethyl acetylene. So this is a simple common name for this third compound. Again, if I take the next example as CH3 single bond C, single bond CH3, single bond again CH3, it is a C, triple bond C, single bond H. Suppose if you want to assign the common name for this example number 4, so how to give the name? So again we have to assign what type of group we can add here. So we add one group by replacement of this hydrogen from the acetylene, that is nothing but the CH3C single bond CH3 single bond CH3, and that is nothing but the tertiary butyl group. So what is the name of this compound now? So it is called as the tertiary butyl. This is the tertiary butyl acetylene. This is a tertiary butyl acetylene. So this is a common name for the given compound. So in this way, it is very simple to assign the names to the alkynes depending upon the common name systems. So what we have to take into consideration according to this common name system. So just we have to take into consideration the common names for any alkynes can be given on the basis of derivative of acetylene. So this acetylene is a parent word. Just we have to add here its derivative. So first is a acetylene. Second example is a methyl acetylene. Third example is a ethyl acetylene, and the next example is a tertiary butyl acetylene. So in this way, we can give within a short time span the common name for the particular alkynes. So this is the first important method for assigning the names to the particular alkynes. Once we take this common name, the second method we have to take into consideration now. This is the first method. First method is a common name system. Now second important method for assigning the names is called as the IUPAC system. This is a IUPAC system. This is a IUPAC system. Now, before taking a particular example for these alkynes, we must know this IUPAC nomenclature system. Now, this system is we already discuss in a last two chapters. One is alkene and second is alkenes. So all that rules we again cannot we repeat it again, but just we have to take into consideration one important rule for this IUPAC while assigning the names to this particular alkynes. Remaining rules are similar to that of the alkenes and alkenes. So all that rules again we cannot take it again and again, but just we have to focus upon the last important rule according to this IUPAC. So whenever a name according to IUPAC is assigned to the alkynes, then what we have to take into consideration? We have to take into consideration the number of carbon atoms present in a given compound. Then accordingly, we have to consider the parent alkane. We have to consider again the parent alkane according to the number of carbon atoms present in a particular alkynes. After that, once we consider the parent alkane, then just we have to replace, the ANE. Just we have to replace ANE of the parent alkane by, just we have to replace this ANE of the parent alkane by the word, there's a YNE, by the word just YNE. Means what? If your parent alkane, whatever it may be, depending upon the number of carbon atoms, then the last word ANE of the parent alkane can be replaced by the YNE. So this is a very important rule while giving the names for alkynes according to IUPAC nomenclature system. So for this purpose, I take one simple example here. This is a, again simple example is a H single bond C, triple bond C, single bond H. For example, again I take the first simple example of these alkynes, H single bond C, triple bond CH. Now, how to give the names for this compound? The common name we already know for this compound, this is acetylene, but what is its IUPAC name? So for this purpose, again we have to take into consideration all the rules of IUPAC. First rule, give the numbering to the particular compound in such a way that you get the longest continuous chain. Then give the numbering to the compound in such a way that your functional group gets the lowest possible number. In this case, what is the functional group? It is a triple bond. So all that rules are similar. Now, if we look toward this compound, it consists of the two carbon atoms. This compound consists of the two carbon atoms. So what is the name of the parent alkane? It is called as ethane. So ethane is the name of the parent alkane. So if we take into consideration this ethane, ETHANE, ethane is there, it is the name of the parent alkane. Now what we have to take into consideration now, this last word, that is ANE, we have to just replace by the suffix YNE. So what is the name of this compound now? So it is called as the ethyne. This compound has the IUPAC name as a ethyne. So this is a simple method for assigning the IUPAC name for the given alkynes. So this is the first simple example of this alkynes. Secondly, if I take another example of this alkynes now, if I take suppose this is a CH3, single bond C, triple bond C, single bond CH3. If you want to assign now the IUPAC nomenclature for the given compound, so again we have to follow the same rules. Now how many carbons is present in the given compound? So 4 carbon atoms are present. So what is the name of the parent alkane? It is called as a butane. So just replace ANE of the butane by the YNE. So it becomes butane. It becomes butane. And nextly, what is the position of this carbon-carbon double triple bond? That we have to also take into consideration. So what is the position? It is a 1, 2. On by either side, number comes to be true. So name of this compound is a 2-butane. It is a 2-butane is there. So this is called as IUPAC for the IUPAC name for the given alkynes. In a similar way, if I take the another example, suppose this is a CH3 single bond CH2, single bond CH2, single bond C, triple bond C, single bond CH3 suppose. So this is another type of the example is there. CH3 single bond CH2, single bond CH2, C triple bond C, single bond CH3. So again we have to count how many carbon atoms is there. So it is a 1, 2, 3, 4, 5 and 6. So 6 carbon atoms is present. So parent alkene is a hexane. Then what is the position of triple bond? Lowest possible number. So from right hand side, if you give the numbering, it is a 1 and 2. So second is the lowest possible number for the position of triple bond. So this compound has a IUPAC name as 2-hexane. 2-hexane is a IUPAC nomenclature for the given particular alkynes. And at the last, if I take the another example, suppose this is a CH3, CH single bond CH3, single bond CH2, single bond C, triple bond C, single bond CH3. Suppose this is a next example for assigning the IUPAC name. It is a CH3 single bond CH, single bond CH3, single bond CH2, C triple bond C, single bond CH3. So again, if you want to assign the names, but to take into consideration the number of carbon atoms present in a parent alkane. So how many carbon atoms is present in the straight chain? So it is a 1, 2, 3, 4, 5 and 6. So 6 carbon atoms is present in a particular parent alkane. So name of the parent alkane is a hexane. Then we have to take into consideration the side chain. One side chain is present in the form of this methyl group at the carbon number 5. Why it is a 5? Because we have to give the numbering from a right hand side in order to get the lowest possible number for C triple bond C. So it is a 1, 2, 3, 4, 5. So the name of this compound is a 5-methyl. At the 5 position, one methyl group is present. So name of this compound is a 5-methyl. 5-methyl. And the next thing is that what is the position of triple bond at the second carbon? So 5-methyl 2-hexane. 5-methyl 2-hexane is a IUPAC name for the given alkyne. So this is a very simple method for assigning the names for the given alkynes. That is a IUPAC system. So we just take an overview of the two type of the different nomenclature system for alkynes. One is called as a common name system, second is called as the IUPAC nomenclature system. According to common name system, the name to the given alkynes is assigned on the basis of the derivative of acetylene. Just we have to take into consideration the derivative of acetylene, and depending upon we can give the name according to this common name system. On the other hand, if we consider the IUPAC nomenclature system, the remaining rules are similar as that of the alkanes and alkynes. Only a last rule get changed. Take into consideration the parent alkane, then replace ane of the parent alkane by the suffix yne. So you will get the respective name according to according to IUPAC nomenclature system. So in the today's video, we start the chapter number 3 called as the chemistry of hydrocarbons, that is alkynes. In that, in the initial part, we take into consideration the important introduction of these alkynes. What is by alkynes? What is the functional group for alkynes? What is the general molecular formula for these alkynes? What type of chemical reactions can be given by these alkynes? And what is by acetylene series? So that we all covered in a introductory part. After that, we completed the two different important nomenclature system. One is the common name system, and second is called as the IUPAC nomenclature system. So with this today, we have to conclude here. I stop here. The remaining points we will cover in the upcoming video lecture. So with this, I stop here. Thank you so much.